we derived the formula of resistance. Resistance is equal to rho L by A in the last lecture, that is factors on which the resistance depend. So there we call this rho as resistivity. Okay, so first let us go to the difference between the resistance and resistivity, the basic difference. So number one is that resistance is a extrinsic property, is an extrinsic property of material which depend upon length, volume, area and mass, etc. What is this? It is extrinsic property. That extrinsic property, because of that extrinsic property, the resistance depend upon length, volume, area, mass, etc. It means if you change the length, the resistance will change. If you change the area, the resistance will also change. So that is my resistance, extrinsic property. Whereas the resistivity of any material is intrinsic property. Intrinsic property. It is intrinsic property, that is unlike the resistance. If you change the length, if you change the area, if you change the volume, if you change the mass of that material, the resistivity will not change, because it is an intrinsic property of material. But the resistivity is different for different material. Okay, so resistivity, this resistivity rho is different for different material. Okay, so for copper the resistivity is something else, for copper, for silver, for gold, etc., etc. the resistivity are different. Okay, and please remember, very important concept, difference, very important difference, that resistivity do not depend upon length, okay, etc., area, volume, etc. So you can also say what are the difference between resistance as unit ohm, and resistivity have unit ohm meter, etc., etc. These are not good stuff to say, only these two are very important. Now let me go to the resistivity. So let me find the equation of resistivity, that you take this R, okay, this R is here, no problem, R is here, and you bring this A here and multiply with R, and this L will come down due to the cross multiplication, and this is rho, or simply rho is equal to R A divided by L. So this is the formula of resistivity. And let me go to the SI unit then. SI unit, what is SI unit of resistivity? So R is resistance, so it has got ohm, and A is area, and SI unit of area is meter square, and divided by length, that is the SI unit of length is meter. So this M will cancel with this square, then we got ohm meter. So some may ask that what is that physical quantity whose SI unit is ohm meter? Then we should be able to say that this is the resistivity. Okay. So now let me have a specific condition. And from here we define a very good quantity, that is, in a specific condition, if area is equal to 1 meter square, or you can say 1 unit, and length is also equal to 1 meter, or you can also say 1 unit. When the length and the area become unitary, then we get that rho is equal to how much? This is equal to R, because A is 1 and L is also 1, so 1 divided by 1 is 1, so we don't need to write. So this is my very versatile equation, where we say that the resistance is equal to resistivity. isn't it? Or resistivity is equal to resistance. From this, what we can say is that the resistance and resistivity are more or less same. Okay, but the condition is that it is same when the area and the length are unitary. Understood? So, since we have considered a specific condition, so because of this specific condition, this resistivity is also called as specific resistance, because in the specific condition, resistivity is equal to resistance. So this resistance is equal to resistivity at the condition specific. So therefore we say that this resistivity is also called specific resistance. So you have also got one experiment in class 12. So resistivity. So resistivity is also called as, what it can be called as is that specific resistance. Okay, so this is all about the resistivity and resistance. Now in the next lecture we go to the conductivity and conductance. Okay, thank you.